So let's do loop counting for triangle 3. This will help us calculate the big O runtime of this code. I'll start with my outer loop. My outer loop uses the variable a, and a is going to start off as 1, and then each time it says a gets, or a equals, a gets a times 2, so next time a will be 2, then multiplying that by 2, a will get 4, then a will get 8, okay. And then what's the last one? The last one is this variable 2 to the n. So my last one is going to be a is equal to 2 to the n. Let's look at the inner loop. So that inner loop, my variable b is just incrementing each time. So here b starts as equal to 1, and then it's going to go all the way up until b is equal to a. So here b is going to go from b equals 1 to b equals 1. Next one, b will start at 1, and it'll execute the body of the loop while b is less than or equal to 2. Or less than or equal to a, so this will go from 1 to 2. Our next line will go from 1 all the way up through 4, so b equals 1 to b equals 4. Last one, b equals 1 to b equals 8. And again, it's stepping through each of these, so this is 8 possible values of b. And my last line, b will start at 1, and it'll go all the way up to b equals 2 to the n. And again, I knew that b started as 1 because in that inner for loop, the first thing it said was initializing b is int b gets 1. So next, let me look at the number of steps in each of these rows. So here in my first row, it looks like 1 step, then 2 steps, then 4 steps, then 8 steps, again because b is just getting incremented, so we'll see 8 separate values, and that inner loop will be run 8 times. And then in my last one, we're going to get 2 to the n steps. I care about the total number of steps. And that total number of steps is just the sum of this right-hand column. This is a common series that we see, 1 plus 2 plus 4 plus 8, yada, 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 all the way up to 2 to the n. When it's this structure, we know that it's 2 times the biggest term minus 1. So the total number of steps is 2 to the n plus 1 minus 1. And that plus 1 is just the result of multiplying 2 to the n times 2. 2 to the n, I'll say that's in O of 2 to the n plus 1. And I think it's reasonable to just say that's in O of 2 to the n.